Good morning, everybody. We're going to be talking about 11.3a surface area of pyramids, and we're saying I can determine the surface area of various types of pyramids. I've got a very specific little pyramid here. I need to just fix one little thing here. I've got a very specific pyramid here that we're looking at right off the bat. And obviously, we always look at the base to try to figure out what's going on. And everything we've looked at so far has actually had two bases. Well, you notice in a pyramid, I don't really have two bases. I only have one base. And this base can take on a lot of different shapes. But this particular one that we're looking at, you notice I've got the right angle markers in all four corners. So this would, in fact, be a square pyramid. Okay, and again, it's kind of named by the base, and so the base is in fact a square here. So it comes to reason that we're still using this same kind of methodology of the fact that surface area equals lateral area plus the base in this fact, okay, because I don't have bases, I only have one base. But it still uses the same methodology. So let's just start here for an example. If I were told that the side of this, the edge of this particular base was 6 meters, okay? So if I were trying to find the base, for example, which is kind of this green area here, if I'm trying to find this base, then I know from previous understanding that the area would be base times height, or as a matter of fact, when we're talking about a square, I can just use the edge squared, okay? So in this case, I can just do 6 squared, which means that would in fact be 36 meters squared. So that part is really quite easy. And it's not that the other part is hard. We just have to think about what this really looks like. So you have to begin to try to visualize. You have to take this 3D object and think about, okay, if I were to cut along all of these little seams, and I'll just use these little blue markings as my cut lines, if I were to cut along all these little seams right here, what would this thing look like? What would it unfold to look like? And so what I want you to understand is this particular pyramid would actually, you would still have your square base. Oh my, I went a little bit nuts right there. You would still have your square base, but notice that you would have 4 triangles that adjoin to that. I know that is really rough looking, but it would have 4 triangles that would adjoin to that. Now, again, let's just think about how do we find the area of triangles. Well, in order to find the area of a triangle, we do half the base times the height. Well, I want you to consider that the base of this particular thing that we're talking about is really the perimeter of the lateral area, okay? So if you think about this base here of this triangle and of that triangle and of that one and of that one is really the perimeter of my triangle, okay? So let's just kind of expand on this just a little bit. It's still 1/2 because we are talking about triangles, but instead of this base here, couldn't we just say that this could be the perimeter? And if you need to break this right on out, you could think about it this way. We really have 4 triangles just like that right there. Now, obviously, those would all be the same height. But what I want you to understand is the base is all the same, okay? It's all the same for this whole thing. So 1/2 of the perimeter would really be the same thing as the base, but what is the height here? Now remember, most of the time when we're talking about height, we're talking about a perpendicular height. But I want you to notice that each one of these sides here, look at this particular side right here. This particular side of this triangle is actually leaned, okay? So when we're talking about pyramids, we need to introduce a new term here, and this new term would be one of slant height, okay? Because this is not just the perpendicular height. Really, the perpendicular height of this pyramid, for example, if we were to draw it, trying to draw it in such a way that you can kind of understand what I'm saying. Okay, the perpendicular height would be like this right here, up and down. If we were looking at this, this is one of the pyramids in Egypt or something, okay? And this is the side of it that we're looking at. This height would actually go down through the center like this, okay? But we're not talking about that height because this is a triangle that's actually leaning down. So we're actually using this, believe it or not, as our height, okay? This would be your slant height. So when I'm talking about the area of these, it's not actually a perpendicular height, it's actually a slant height. Okay, so we're gonna kind of use that, and we're gonna use a new symbol here. Okay, we're going to use the letter L, and this is just what they use in the book, and it's what's used kind of across the world, so we'll use that. But L is what we're going to define as slant height, this cursive letter L, okay? So when we're talking about the lateral area of a pyramid, okay, when we're talking about the lateral area of a pyramid, then this is what we need to use. So let's go over this again real quick. We have a surface area of a pyramid is going to equal 1/2 P of L, which again is our lateral area, plus our basis, whatever kind of base that it is. Now, this one in particular had a square base, so we kind of already figured out that the square base is 36 meters squared, okay? Let's say, for example, that this slant height right here in red was 8 meters, okay? So let's think about what we could put into this particular problem to help figure this one out. So again, I don't know what this is down here. It is freaked out on me. All right, so we got 1/2 P times L. Let's think about the perimeter. If this is truly a square, then that means this also has to be 6 meters, this has to be 6 meters, and this one has to be 6 meters, okay? Add those all together. I'm going to get 6 times 4, which is 24. So 1/2 times 24, which is my perimeter, okay, times my slant height, with that, which they have told me here is actually 8, okay? So 1/2 times 24 times 8. And let's see, 1/2 of 24 is 12. 12 times 8 is 96 square meters. So this would be my lateral area. This is my base that I've already been given. So what do I do to find the surface area? I'm going to take lateral area plus the base. My lateral area is 96. My base is 36. So that, in fact, equals 132 square meters. Okay? So again, let's just review real quick what the important formulas are here. To find the lateral area of a pyramid, you're going to use this right here, which is 1/2 perimeter times the slant height. Okay, and then for your base, you're going to use whatever you have. In other words, you may be given a square, you may be given a rectangle, you may be given different things. You only have 11 questions on this particular one. So again, the important thing to make sure that you recognize is whether they are pointing to the slant height, like this one right here is pointing toward this actual side length, if you want to call it that. Okay, if you have something that comes down in the middle like this, and it has a little perpendicular box like that, then I want you to understand that really what they're giving you there is they're giving you the actual height, okay? You're going to need to find the slant height, which is the L right here, in order to really be able to do this effectively. All right, if you have any questions, make sure that you reach out to us. Again, I know this is very difficult to try to teach online. It's difficult enough in person, but online it's really difficult. So make sure that you reach out to us if you need help in particular, and we'll make sure to go over this with you. Thanks.